I'm really delighted that tonight we have a panel of experts to offer their perspectives and for you to ask questions. And what's really great is they all come from different perspectives. So delighted to have Tom Faure here from IBM. He'll bring more of the mass perspective. Bob Pack here from GlobalFoundries bringing the wafer manufacturing perspective. Nakayamada-san here from NuFlare bringing us the equipment supplier viewpoint, and Aki Fujimura from D2S bringing the design automation viewpoint. So I'm going to start and ask a few questions, and then we'll open it up to the audience. So I'm going to start with Tom because I happen to know that they did a pretty extensive review of the results in preparation, and I'm curious kind of what was the overall feeling and response to the survey results.
So we went through the survey with members of the mass shop and the computational lithography team. As far as the survey, we found it helpful in confirming the trends of the slower resist, the need for the dose modulation, and also certainly the multi-beam adaptation. So, and we were impressed by the response rate of the survey, Jan. The other thing we wanted to comment on a little bit was on the slide 4 of taking advantage of the multi-beam when it becomes available with the complex ARF masks. So the computational lithography folks reminded us on the mask optimization front there were several things that stopped us in the past, not just shot count, and that those would all have to be addressed. So what we mean by that is, do we have an inspection solution? We're kind of single chip reticles, so we're think of inverse lithography. Can we do data database on kind of what I call the crazy OPC as the mask maker? Or are we going to be stopped there by MRC due to inspection limitation? Or do we have processes that can make these small shapes, these complex shapes with good resists, blanks, and such to resolve them and put them in the right spot from a placement accuracy standpoint? The other is the OPC runtime. We have to, if we want to do full chip of the inverse lithography, have we addressed that? Or do we keep the path of just doing localized hotspot OPC? So just want to remind folks that to take advantage of it there, we need to make sure we have the other items on the list crossed off.
Okay, very good. Bob, turning to you on that same point about the complex mask shape from a wafer manufacturer, how do you view complex mass? Is that going to be a difficult challenge?
So as far as being a representative of the wafer manufacturers, I've only been with Global for a fairly short time, so I'm not sure if I can fully represent the wafer manufacturer's viewpoint. But I will tell you that masks are extraordinarily complex in any manufacturing organization. An OPC organization, I was shocked. I've been involved with lithography simulations since the beginning, and so seeing how a OPC organization works was quite an eye-opening experience. So a given layer on a mask will involve thousands of computers running for a very long period of time. So optimization of an OPC mask is crucial. And it's important to make a mask that is as simple as possible, but not simpler, that will accomplish your objective. And one other point is that increasingly OPC tools, so ORC tools, are so extraordinarily accurate compared to silicon now that OPC is a really very significant part of the overall lithography solution. So you must have accuracy, you must continue to have accuracy, and when things go wrong, quite often it's the OPC group. So accuracy is key. Models are extraordinarily important. Mask complexity, have to keep it as simple as possible. Minimal shot count. It's about all I can say. Thank you.
Aki, I'm wondering if you could maybe respond, because I know you've spent a lot of time on this topic, to Tom's point that, is everything in the supply chain going to be ready?
Yeah, I don't think I have an answer, but I think it's a great question. The interesting one is the inspection question to me. I think there's a lot of different things going on in that area, but perhaps wafer plane kind of an approach is one of the ways to address it. I'm not sure. I think in either case, the OPC question as well as this question, increasingly there is going to be a need for GPU-based computing is what I think. It's there's so much simulation that has to occur at every step of the process. I think the only way to get it done in reasonable time and maintain accuracy is to use GPUs.
Wow, gosh, perfect setup. I promise it wasn't planned, but I wanted to move to that question next because I said I wanted to get the perspectives on the GPU usage question since, again, there's a lot of I don't knows to this. So Nakayamada-san, I'd like to start with you and see what your perspective is on this. Do you agree with these results or are you seeing something else?
I was a bit surprised that many people voted for I don't know, but I think this is indicating that GPU is getting more common technology and not so special anymore. And probably the true meaning of I don't know is I don't care as long as they can get good results, no matter what the background technology is, GPU or FPGA or CPU or whatever. But in case of our machine, I can send more strong message that current eBeam 7000 and 8000 is using 2 GPU per 2, but its next platform is going to use 2 digits or maybe 3 digits of GPU per 2. So we are counting on GPU technology.
Okay, so quite a different response than the survey would reflect. Any other comments from the panelists on GPU? Yeah.
So I've had the opportunity to spend quite a bit of time doing the types of simulations that I showed using actually D2S's machine. So I had the opportunity to consult for D2S a couple of years ago on a project that involved doing Monte Carlo simulation of ILT. So ILT typically is very complex, but both by having overlapping shots on an ILT and by doing simulations with the GPU allowed me to do Monte Carlo simulation on an ILT. So a publication of 2 years ago or so. So my opinions about GPUs now, they're in cell phones. I mean, people talk in the new iPhones. They talk about the GPU performance, and likewise Androids. They're just a processor, and you have to use what's best for the job. These kind of calculations, GPUs are outstanding for because GPUs, in terms of a bit of computer science, they love Gaussians. So Fourier transform of Gaussian is Gaussian, and so you like to do convolutions, you can do it very fast. So whereas you may need thousands of regular CPUs, you can use far less in terms of GPUs. It's just a box, and they're cheap, you can buy it at Fry's. So the business model will determine whether they're adopted. There's no need necessarily to talk about GPUs.
Okay. All right, so let me move to a different question and get, the question we started with. Let's see if Nakayamada-san, if you have any comments about the result on dose modulation, in particular, kind of, that was asked around 2016 versus the reality today.
Yeah, in 2016, there are even 5,000, 6,000, which does not use high multiple level of dose. Still working in place. So I was surprised that nobody voted for zero level or single level dosing in 2016. But yes, we understand the customers' request to go higher multi-level doses. And we are offering that capability on eBeam 7000, 8000, and 9000. And what makes me sad a little bit was for more than 2 decades, our PC was satisfying your request, but it's now giving way to the EDA vendors too. So, and I need to give one warning. Because of multi-dose capability, the write defect looks like dose error is not solely our responsibility. So please don't come to our office and, hey, your tool has write defect, dose defect, please fix it, but before you check the pattern data of multi-dose.
Okay. You heard it here first. Okay, let's stick with the question of surprises, because Tom, I think you had a few that you thought were surprising results. What were they?
Okay. So with, basically 2. One was the increase, significant increase in the pessimism for EUV. So no secret, IBM has said publicly, and it is our upfront approach for 7 nanometer is EUV, and we're investing and have invested a lot into it. The optical option for 7 nanometer is extremely challenging. So I think the increase in pessimism on EUV was somewhat surprising, and kind of conversely, the increase in, I'll call it optimism on CEBL, the complementary eBeam lithography.
Anybody else have any comment on those?
Do you think it's possible that while there's no dispute that it would be great if EUV was available, people just think that it might take even longer or something?
I mean, there were a lot of folks that were hoping it would be available at 10. Right. And, or even back at 22. So, but really, when we look at, as the keynote showed in Martin's talk, it's just really, we've hit the wall at 7 nanometer. I mean, the amount of complexity to come up with an optical solution at 7, EUV is needed, truly needed.
But go back now to the multi-beam for mask writing result. Did that surprise you, Nakayamada-san?
Yes, a little bit surprised, but it's also a good news for us, single beam maker, so that we can sell a little more tools in a year or 2. But I think multi-beam is in the second phase of hype cycle. Have you ever heard of hype cycle?
Yes, the Gartner.
Yeah, between the inflated expectation and disillusion, disappointment. It's now entered into the second phase, and if it can clear the second turn, upturn, then it will be a real promising technology for production.
Any other comments from the panel on this? Tom, do you agree with the survey results?
For
2018 for multi-beam for mask writing?
yes, yes.
So then let me just wrap up with one for Bob. Can you help us with, the 17% who don't know on mask hotspots? Any particular message for them?
Well, I'm not sure that it's really been generally understood what it really meant. It is one of those topics that involves both the mask and the wafer. In traditionally siloed organizations, quite often just think about their own results. OPC will think about OPC results, and the mask will think about their results, and wafer think about their results. But I think actually there's some competing, or I should say some effects that tend to enhance the for example, MEF and the mask errors can multiply the effect dramatically, and it can be pretty subtle, as I showed.
So should they be doing something to get ready?
I think so. I think, hopefully the talks we gave at BACUS today and this talk will get some of the good thinkers to think about this more. I do think, we've all heard for years that you must account for all sources of potential errors because of the diminishing total budget. I think that this is a potential area where we can add some lost process window through some relatively simple methods to mitigate these potential mask hotspots.
Well, very good. Thank you all for providing your perspectives.